Stop memorizing all the formulas for physical chemistry. Just learn about this super trick and solve any question under 10 seconds. What is N? N is Avogadro's number. Thinking balancing a chemical reaction is a hard topic, not from now onwards. Hey everyone, welcome back to our channel PcmbGeek. Today we are diving into the basic concepts of chemistry. So grab your notebook and let's get started. So you can find these notes, sheets and solution from our Telegram channel or our Pinterest page. Now we are starting from the beginning. Matter is anything that occupies space and possesses some mass. It has three fundamental states: solid, liquid and gas. Solid has a fixed shape and volume, whereas a liquid state possesses a fixed volume but not fixed shape. And chemistry. Robert Boyle was the founding father of chemistry, father of modern chemistry. Antonin Lavoisier. Pure substance can only be the element. So the term element. What is element? Element is the purest substance. There are altogether 120 plus elements till now. What is atom? Atom element is composed of smallest particle, that is known as atom. It is indestructible. What is molecule? Molecule is the smallest particle of an matter. Term element. The term element was proposed by Robert Boyle. So term atom was proposed by John Dalton and molecule was proposed by Avogadros. To our next subtopic, that is law of chemical composition. These four laws was based on the principle of Dalton's atomic theory. Law of conservation of mass. The law of conservation of mass was proposed by Lavoisier and verified by Landrewich. So as we know that just like energy, mass neither can be created nor be destroyed. So it can only be changed from one form to another. Similarly, the law of conservation of mass states that for any chemical reaction, mass of reactant is equals to the mass of the products. Every law has some exception and flaws. Similarly, the law of conservation of mass doesn't work for nuclear reactions. So law of constant proportion was proposed by Prost and verified by Richards. It simply states that a given compound will contain exactly same proportion of elements by their weight, irrespective of the origin. Any chemical compound consists of isotopic elements. It does not apply the law of constant proportion. Move on to our third law, that is law of multiple proportion. It was proposed by Dalton and verified by Berzelius. Simply it states that when two elements form multiple compounds, the mass of one element combining with a fixed mass of other are in simple whole number ratio. It does not work for three scenarios. First limitation of this law is for isotopes. If any compound consists of the isotopic elements, then law of multiple proportion does not work for them. In scenario where the law of multiple proportion does not work is hydrocarbons. Or scenario where the law of multiple proportion does not work is for complex compound. Sometimes the complex compounds may be non-stoichiometric. Then the law of multiple proportion fails to satisfy this statement. The fourth most important law is Avogadro's law or Avogadro's hypothesis. Avogadro's law was proposed by, obviously as the name suggests, Avogadros, which simply states that equal volume of all gases at the same pressure and same temperature contain the same number of molecules. Or we can simply say that volume of certain gas is directly proportional to the number of molecules at temperature and pressure condition, which is simply isothermal and isobaric conditions. This hypothesis only consider about the ideal scenarios, so it is only applicable for ideal gases. Now let's move on to one of the most important topic, that is mole concept from the basics, right? Suppose you want to quantify an apple. How you are going to do that? By just saying I need 1 kilograms of apples. Similarly, the mole is the unit, just like kilogram, meter, second, that is used to represent the amount of something. Here is the all of the important concept regarding to the calculation of moles that you need to understand carefully. Okay, simply you can understand it by number of molecules equals to the volume of gas at certain temperature and certain pressure divided by 22.4 liters. Simply number of moles is the number of molecules of certain compound or element divided by Na. What is Na? Na is in something constant, which is simply Avogadro's number. It just represents the number of unit in 1 mole of any substances. The number of molecules contained in 1 mole of any substance or element or compound is said to be Avogadro's number. 1 Na equals to 6.022 into 10 raised to the power 23. Kind of elements, you can calculate the number of moles by given weight of certain element divided by molecular weight of that element. 1 atom equals to the reciprocal of Avogadro's number, or simply 1 atomic mass unit equals to 1.6 into 10 raised to the power minus 24 grams. To our next topic, that is modern atomic mass. Modern atomic mass is a relative concept. Let's move on to the theoretical concept of mole concept. Our modern atomic scale is based on carbon 12 atom, which simply equals for 1 atomic mass unit, or 1 atomic mass equals to 1/12 part of carbon C12 isotope, which is nothing but 1 divisible by Na, which is nearly equal to 1.6 into 10 raised to the power minus 24 grams. Let's jump to our second topic, that is molar mass. The mass of 1 mole of any substance, element or compound is said to be molar mass, or the mass possessed by Na molecule of certain compound or element is said to be molar mass. Its unit is gram per unit mole. 1 mole of hydrogen atoms equals 1 gram. Every compound is made up of 2 or more elements. So if you want to say an element is an compound is formed with an element A, so what is the percentage composition of that element A? So you need to understand this formula. Percentage composition of A in certain element is equals to atomic weight of A divisible by total molecular weight of that compound multiplied by atomicity of A into 100%. As we are calculating the percentage composition, we can calculate the absolute density for gas by PV divisible by RT. And the relative density, relative velocity of relative density, for both we need to have some reference quantity. Similarly, for relative density, we have taken density of water at 4 degrees centigrade. You need to also memorize that water at 4 degrees centigrade shows the anonymous behavior, which is simply it possesses the maximum volume and least density. The relative density of certain compound is density of that element or compound divisible by density of water at 4 degrees centigrade. So you need to memorize density is directly proportional to molecular mass. Now, what is vapor density? The density of the gas with respect to hydrogen gas at identical temperature and pressure condition, or simply you can say it best isothermal and isobaric condition, is said to be vapor density. You need to understand this as 2 times vapor density equals to molecular weight of something. Now let's move on to our second topic, that is combustion of hydrocarbon. When hydrocarbon burn in the presence of oxygen, they produce carbon dioxide and water. The general equation is this. You can also memorize it as a trick, so that you have no worry of solving any kind of combustion trick by manually. You can just memorize this formula. Let's move on to our first problem of this chapter by this key. The amount of oxygen required for the combustion of 1 kg mixture of butane and isobutane is. Fundamentally, you need to understand what is butane and what is isobutane. They both possess the same molecular formula, that is C4H10. So by applying the above trick, you can solve for the coefficient of O2, CO2 and H2O. For the complete combustion of 1 mole of butane and isobutane, it will require 13 divided by 2, where 6.5 moles of oxygen atom. So for 1 mole it will require 6.5 oxygen atom. In weight format, for the weight format, for 56 gram of mixture of butane and isobutane, it will require 208 gram of oxygen. So similarly, for 1 kg you can solve by applying unitary method. It will require 3.58 kg of 3.5 kg of oxygen. Now our next topic is empirical formula. The empirical formula is the simplest whole number ratio of atoms present in some compound, or you can understand it by molecular formula divisible by some n. N is that the simplest whole number ratio it gives the empirical formula. You can solve this question by your own. What is limiting reagent? Simply something that is limiting to complete a certain reaction properly. Like your procrastination is limiting you to reach your desired marks. So the procrastination is limiting reagent. In simpler words, the reagent or reactant that's consumed earlier it's said to be limiting reagent. Let's look at the numerical that's asking for which one is limiting reagent. The problem is which one is limiting reagent if 8 gram of methane reacts with 48 gram of oxygen. Solve for this coefficient by applying this super trick. This type of question you need to write the given weight at first. That is, in question it is given that I have written the 8 gram in the below of methane compound and 48 gram in oxygen compound. The required mass of reagent from the balanced chemical equation CH4 equals 16 gram of CH4 and 2 moles of O2 is 64 gram of O2. Now all you have to do, that is 8 divided by 16, that is 0.5, and 48 divided by 64, that is 0.6 values. Which one is less? That is the limiting reagent scenario. 0.5 is less than 0.75. That's why methane is the limiting reagent. Now at the meantime the electricity has gone. That's why I am taking the help from flashlight. What is equivalent weight? Is the part by a mass of an element that displaces 1.008 part of hydrogen or 8 part of chlorine or 35.5 part of chlorine. Molecular weight of copper is 64 grams. Whether the equivalent of weight of copper may be 32 gram or other. You can simply memorize the equivalent weight as atomic weight divided by valency or molecular weight divided by total change in oxidation number. Weight of metal divisible by weight of hydrogen atom displaced into 1.008 or weight of metal divided by weight of oxygen into 8 or weight of element into 35.5 divided by weight of chlorine liberated. Atomic weight into specific heat equals to 6.4. Specific heat method is only applicable for gases for determining atomic mass of that gas. For solving the numerical, you may require this formula as valency of certain element equals to 2 times of Vapour density divided by equivalent weight of metal and equivalent weight of displaced element. That displaced element can be either of hydrogen, oxygen and chlorine. The problem is when 0.344 gram of tin combines with oxygen to give 0.4365 gram of SnO2, equivalent weight of tin for this reaction is. To understand what is the symbol of tin, that is Sn, when it reacts with oxygen it gives SnO2. The weight of Sn given is 0.344 gram, is given is 0.4365 gram. If any question is coming from the physical chemistry, from the chapters like mole concept, electrochemistry, titration, you can solve every numerical by this formula, that is, or by this trick, which is simply weight of certain compound or element divided by equivalent weight of that similar compound or element equals to something constant, that is K. Let's suppose it as X, and SnO2 is consist of 2 element Sn and O2. For equivalent weight of S, assumed it as X, and for O2 the equivalent weight of oxygen is 8. For solving for the value of X we get 29.75 grams. So the equivalent weight of tin in this chemical reaction is 29.75 grams. Solve all the questions from mole concept or simply from physical chemistry. It is basically like second law of Newton's, that is force equals to change in momentum divisible by time taken for the change in momentum. For more videos, stay tuned.